Welcome to ITW EAE here at Productronica. I'm joined by Hugh Read. Nice to see you here. Good morning. So we're looking at the Prodigy, which is your latest dispensing system.
Correct.
Which has a special head on it. I'll let you
Thank you.
explain how it works.
Excellent. Yeah, so this is the Prodigy system. Probably 2,000 systems sold worldwide. We're showing tilt and rotate. Mm-hmm. So tilt and rotate was driven from customers' requirements to get more components on the circuit board. Mm-hmm. So when we apply this to the underfill application, it puts less wet out area from the side of the component. So there's more area for other components and obviously power for whatever the customer wants to develop into their product. So,
and that's also environmentally friendly, which this week has turned out to be
sustainability is a big thing.
It's
that's
a big thing these days.
So. It is certainly, and we're being challenged in other industries as well on the size of products as well. So underfill was typically in a smaller products. Mm-hmm. Some of the larger 5G servo applications now are requiring underfill. So it's a challenge to us because we've got to heat a larger board and transport a larger board.
That's
so some of the applications are coming in on boards 800 by 600.
Wow.
So there'll be some further developments I think we'll see later on next year that will require.
So you've got it looks like you've got quite a big board area in there. I mean, so you can obviously accommodate these big, large.
We can go out to the 600 millimeters, and the way we'll do a larger board is we'll stage the board in, dispense the maximum area, and then index it, and then we'll have the other side of it as well.
Yeah, absolutely.
Which is great.
So looking at the tilt and rotate, I mean, what are the parameters on that? I mean, it's showing here going 90 degrees.
Yes.
Tilt in what, 2 axis?
Correct. So both the tilt and the rotate axis have a DC servo control. We call it a harmonized drive. It's a rotary drive unit. Okay. So we can program by the 0.01 degree for the tilt and the rotate. So typically the limitation was a pneumatic rotate before, so it was 0 or 90, but we see components mounted at 45 degrees.
Yes.
So this again can accommodate that. Mm-hmm. There's a motor resolution of 0.01 degrees, so it's very accurate as well. So we're not really losing system accuracy implementing tilt and rotate.
Excellent, super. Okay, wonderful. So I think I don't think there's much else that we can really talk about on this one, so let's move on to the selective soldering system. So here we are on the selective soldering side of the ITW EAA stand, and I'm joined by Colijn.
Yes.
Nice to see you, Ton.
Thanks for having me again.
Yeah. Now, one of the things that differentiates you from other selective soldering companies is the fact that you make your own 3D printed nozzles.
Yeah.
What are the benefits for creating these using 3D printing?
Yeah, so that's indeed quite a differentiating value, I would say. Most of our competitors, if not all, are using wetted nozzles. Yeah. They work quite fine. They're also a little bit less expensive, but they need quite some maintenance. You need to maintain wettability, so you need quite some nitrogen to do that, but you also need to clean them on a regular basis, and they wear out, especially in a lead-free environment. Right. With a copper-containing alloy, they wear out quite quickly. Mm-hmm. We have stainless steel nozzles, which have a chromium coating, so they will last pretty much forever. And since recently we are 3D printing those nozzles. That gives a lot more freedom in your design. Mm-hmm. We have square nozzles, we have rectangular nozzles, especially the angle and the radius, which we can do with 3D printing, is quite a big benefit. So we reduce the amount of maintenance, we reduce the amount of nitrogen to be used, and we have more flexibility in those.
Right. Okay. And you get a nice shape of wave coming out of that.
Yeah. We can see that on the screen. And additional, we have what we call the BPT, bridge preventing technology, which is really a key feature to go to a big process window for fine pitch soldering. We can really go back to 1 mm point-to-point soldering with, let's say, very limited amount of design rules, pin length, etc., per diameter. We can do that. We have done a design of experiments, and we know that we have a big process window with the BPT.
Great. So looking into the machine itself, I mean, if we start off with the fluxer unit, a lot of companies are looking at sustainability and this type of thing with the machines and trying to save energy. We don't want to be doing spraying excess flux around the place. Correct. So what have you done to try and limit that?
Yeah, we have an HF nozzle that's high frequent. That means we have tripled our frequency for more accuracy. So that means we can get small droplets into the areas which are requiring soldering. Especially with Selective, it is also very important that we don't get the flux outside of the area which is going to be in contact with solder, because you need to deactivate the flux.
Right.
So we have also developed a software program which is calculating the spread factor. A lot of fluxes were designed for wave soldering and needs to be spreaded, which is something we don't want, because we have a small area where we do the soldering on itself. So we have calculated a software which is calculating the spread factor, so we apply only the flux in the areas where we solder.
Right, okay, excellent. So then you move forward into the preheat area.
Yeah.
Now your preheating's using IR lamps, but you've done something to stop them spiking, really. I mean, just try and just bring the heat up gently.
Yeah, more gentle indeed. And in our previous platforms, we were flashing the lights a little bit in order to get to the good temperature profile. But we found out, mostly with the environmental friendly thoughts we are having, that we were heating up the glass from the lamps and cooling down the glass of the lamps, where we were losing quite some energy. So we have changed the controls that we have more a gentle preheating profile.
Yeah, I'd imagine the lamps don't last as long if you're flashing them like that as well.
To be honest, that's surprising, because the same lamps we are using already over 20 years and they have been very reliable. Okay, you need to treat them gentle, of course, but when you are running them and you are safe with them, they are lasting very long, even with the spiking and the flashing.
Okay.
So in that sense, that is not the big problem, but we are saving quite some energy, to be honest.
Okay.
Yep.
So moving into the actual area, the soldering area here, where we've got the pot, we've got you've got an overhead gantry basically handling the board, which is quite flexible too, because you've got a tilt system in there.
Yeah, so our previous platform, we only had the tilt capability, but we were moving the board, which is, let's say, a benefit because of the flexibility of the tilt, but also a drawback because of the changeover time. Right now we have changed that whole design. We have a moving pot, so that also means that if we are changing the width of a PCB, automatically the system is changing over, so no changeover time anymore. But we saw that the benefits of having a tilt, especially for keep out areas and for fine pitch, was still a benefit. So we have a third section conveyor in our machine, and the third section of conveyor with the moving pot, which is by the way patented, we can tilt in an X direction and in a Y direction, which is a benefit for fine pitch, but especially also for keep out areas.
Absolutely, absolutely. Okay, and then I think possibly the final point is that you're making this available to do much larger boards. Yeah, we have been introducing, let's say a month ago, we have been introducing this machine, which was originally designed for 16 inch or 410 mm. We see that the demand for the EMS market is bigger boards, and that's a trend which we see anyhow. So we have been able to get this to a 508 millimeter or 20 inch board production, or board dimension, and which is pretty much what everybody is doing, but really what's the nice thing is we did it with the same footprint. So we have a really nice small machine with 3 modules, fluxing, preheating and soldering in a small footprint, and still being capable with all the features we are having to do a 20 inch or a 508 millimeter board width and board length. Right. Well, that's great. You've kept it all in the same footprint, and it's pretty flexible then, you know. You can do a smaller board or right up to the big ones. And
correct.
That's super. Ton, I want to thank you for giving us a walkthrough today.
Thanks for having me. Thank you.
Okay.
Without reliability, with reliability, a world of difference. Welcome on the journey to better reliability outcomes.